We often think of learning as something exclusive to living beings. We study, we adapt, we evolve. But what if I told you that the universe itself is constantly learning? It might sound strange, but the principles of learning are woven into the very fabric of reality, from the smallest atom to the largest galaxy. Consider the simple act of folding a piece of paper. Each crease you make, each fold you create leaves a lasting impression. The paper learns the shape you're teaching it. This is a basic example of how physical systems, not just biological ones, can exhibit a form of learning. This concept extends far beyond paper. Rocks under pressure, metal subjected to heat, even the very ground we walk on. They all learn and change based on the forces they experience. By understanding these processes, we unlock a deeper understanding of the universe and our place within it. Join me now as we journey into the fascinating world of physical learning systems, where we'll discover that the universe is not merely a stage, but an active participant in the grand dance of existence. Let's take a closer look at that folded piece of paper. Each time you make a crease, you're not just altering its form, you're creating a memory. The paper remembers the fold, and this memory influences how it behaves in the future. Unfold it and the creases remain. Try to fold it a different way and it will resist, wanting to fall back into its learned pattern. This simple act has a profound parallel in the cosmos. Einstein taught us that space and time are not rigid backdrops, but a dynamic fabric warped by gravity. Massive objects like stars and planets create folds in this fabric, much like those creases in our paper. These folds are not just abstract concepts, they dictate how other objects move through the universe. Think of a comet, its trajectory bent by the sun's immense gravity. That bend is a testament to the sun's influence, a cosmic crease in the fabric of space-time. The universe is constantly being folded and reshaped by these forces, leaving an indelible mark on its structure. Now let's consider another everyday material, clay. Unlike paper, clay is malleable. You can mold it, shape it, and it retains its new form. This is what we call plasticity, the ability of a material to undergo permanent deformation under stress. Plasticity is another remarkable example of learning in the physical world. The clay learns from the pressure of your hands, changing its shape to match the force applied. This principle applies to a vast array of materials, from the molten rock deep within the earth to the metal used to build our bridges and skyscrapers. Even our own bodies exhibit plasticity. Muscles grow stronger with exercise, bones adapt to stress, and our brains rewire themselves as we learn new skills. These are all examples of physical systems responding to external stimuli and learning from the experience. This brings us to a fascinating parallel between the physical world and the biological one networks. Our brains are complex networks of neurons, interconnected pathways that transmit information and learn from our experiences. But did you know that similar networks exist in the inanimate world? Consider a spider web, a marvel of natural engineering. Each strand is connected, distributing tension and vibrations across the entire structure. When an insect becomes trapped, the web learns about its presence through these vibrations, allowing the spider to locate its prey. This concept of interconnectedness and information transfer is found everywhere in nature, from the intricate root systems of trees sharing resources to the global network of weather patterns. The world around us is constantly communicating and adapting. Section 5, the laser universe, energy minimization. So what drives these physical systems to learn and adapt? The answer lies in a fundamental principle of the universe, energy minimization. Simply put, the universe prefers to exist in a state of lowest energy. Think of a ball rolling down a hill. It naturally seeks the lowest point where its potential energy is minimized. Similarly, physical systems tend to rearrange themselves to minimize their internal energy. This drive towards equilibrium is what we observe as learning and adaptation. The folded paper seeks the lowest energy state defined by its creases. The clay conforms to the shape that minimizes the stress within its structure. Even the universe itself, expanding outward since the Big Bang, is constantly seeking a lower energy state. Section 6, from mountains to microchips, examples of learning in nature. This principle of energy minimization plays out on scales both grand and minuscule. Consider the majestic formation of mountains. These colossal structures are not static, but are constantly reshaping themselves in response to the immense forces within the Earth's crust. Over millions of years, they erode, crumble, and rise again, always seeking a state of equilibrium. At the opposite end of the spectrum, the tiny transistors within our smartphones and computers rely on the same principle. Electrons flow through these microscopic circuits, seeking the path of least resistance. This flow of charge is what allows us to store information, process data, and connect with the world around us. Section 7. The Future of Learning, Bio-Inspired Materials and Beyond. Understanding these principles of physical learning has profound implications for the future of technology. By mimicking the way nature learns and adapts, we can create materials that are stronger, lighter, and more resilient. Imagine self-healing materials that repair cracks like our own skin, or buildings that adapt to changing weather conditions. We're already seeing the emergence of bio-inspired materials that mimic the properties of spider silk or the intricate structure of bone. As we delve deeper into the secrets of physical learning systems, we unlock the potential for innovations that can revolutionize industries from construction to medicine and beyond. Section 8, Conclusion, A Universe of Learners. As we've explored, the universe is not a static, unchanging entity. It's a dynamic, ever-evolving system where learning is woven into the very fabric of existence. From the smallest atom to the largest galaxy, everything is in a constant state of flux, adapting and responding to its surroundings. By recognizing the principles of learning in the physical world, we gain a deeper appreciation for the interconnectedness of all things. We begin to see the universe not as a collection of disparate objects, but as a vast interconnected web of information and energy, constantly learning and evolving. So the next time you fold a piece of paper, mold a piece of clay, or simply marvel at the natural world around you, remember this: you're witnessing the universe learning. And in a very real sense, you're a part of that process too. For as we continue to explore and understand, we too are learning, evolving, and becoming one with the cosmic dance of existence.